Good afternoon. We are going to do the second part of 4.2 today, isosceles and equilateral triangles and their applications. Okay, first off, corollary 3 to isosceles triangle theorem says that the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Alright, so just to review that when you have an isosceles triangle, it means there are two congruent sides. The angle in between the sides is called the vertex angle. And the side that is not congruent to the other two here is called the base of the triangle. So what this is saying is if you drop a line straight down from the vertex to the base, it has lots of really good things that happens. And the expression, by the way, is to drop an altitude. Altitude is like dropping a rock off a cliff. It goes straight down to the bottom. And if you do that from the vertex angle, it is perpendicular to the base side, so you get a nice right angle. And it also splits the base into two equal pieces, which basically gives you two congruent triangles. The angles at the top are also, because this is a bisector, those two are the same by the definition of an angle bisector. So it's perpendicular, it bisects the top angle, it bisects the opposite side, and you have two lovely right triangles. Okay, so let's do an example of this. Given isosceles triangle PRS with perpendicular bisector PQ. Okay, so if this is isosceles and this is the perpendicular bisector, these two sides must be the legs. It's a bisector because it bisects the base into two equal pieces, and it is perpendicular. It also splits the top angle into two equal pieces. So angle PRS, which is this one, and PSR are congruent. That is true. We'll mark those congruent. And that has to do with our isosceles triangle theorem, that the angles opposite the congruent legs are congruent. Segment PQ bisects RPS, right here. It bisects the angle into equal pieces. PQ also bisects this side into equal pieces. PQ is perpendicular to RS at point Q, yep. And last but not least, triangle PQR, which is the left one, is congruent to triangle PQS. And the one piece of information that we add is that they both share side PQ. PQ is congruent to itself because that's reflexive property. So we can add in there PQ congruent to PQ because of reflexive property of congruence. So I have 1, 2, 3 matching angles, 1, 2, 3 matching sides, which is why we know that these are congruent. Additionally, both triangles are right triangles because they both have a 90-degree angle. And this is really nice because it means that you can use Pythagorean theorem to relate the sides of the triangle. Remember that? A squared plus B squared equals C squared. Because these are right triangles, we can use that for the left triangle or the right triangle. So lots of good information there. All right, let's do an example. What is the measure of angle RSQ? RSQ. So we're looking for this angle measure right there. Okay, and this triangle is isosceles because it's got two congruent sides. The theorem says that if you have two congruent sides, then the angles opposite those sides are congruent. So if this one's 31, this one must also be 31 degrees. All right. Now that we've got the angles, we can tell that S is actually split evenly between the one we want and the other side, but we can use triangle sum theorem to figure out angle S. So let's do this. So 31 plus 31 plus angle S has to be 180 degrees. 31 plus 31 is 62, so angle S plus 62 is 180. Subtract 62. So angle S is 180 minus 62. Let's borrow. Let's see, that's 118. And the one we want is half of that. So the measure of angle RSQ, which is the one we want, is half of 118, which is 59 degrees. 59 degrees. All right, so what is PR? Okay, so we know that QR is 4. The question is this a perpendicular bisector? We know it bisects the angle. The question is it perpendicular? That would mean this angle has to be 90. So if you take 31 plus 59, those two are 90. Since all three have to be 180, this one has to be 90 degrees. Now that we have a perpendicular bisector, we can use the corollary to say that it bisects PR. So PQ must be 4. That would mean that P to R would have to be 8. All right, flip the page. Okay, we're going to be doing quite a few application problems in this section. And they look fancy, but they're actually not that fancy, especially if you draw a diagram off of the picture. This says a prefabricated house is delivered to a foundation in 2 symmetrical halves that are assembled on site. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? Okay, so it says that they have 2 symmetrical halves. So this house is actually split into 2 halves. Let's draw just that front face of the house to make it a little easier. So we've got 2 sides, and it's identically split with a peak at the top for the roof. There we go. They tell you that the roof lines are both 16 feet. They tell you that from the bottom edge to the roof is 10 feet. And that the entire bottom, from here over, is 28 feet. And the question is, how tall will this be so it will get under the bridge that has a clearance height of 17 feet? Okay, here's the secret to this one, if there is one, is to recognize the fact that if you drop a line straight down, it is perpendicular. It also splits this angle. But we can actually draw a line here on the diagram that creates 2 right triangles. That will give us a way to calculate. If this is 28 feet from side to side, then because this is a perpendicular bisector, it's straight down and it's perpendicular, we can split this into equal pieces. So half of 28 is 14, so I have 14 and 14. Now I need to know the total height. I know this far is 10, but I need to know how far this is. So that's going to be our x, is how do we find the length of that side? Well, this is a right triangle, so we can use Pythagorean theorem to relate the sides. Pythagorean theorem says that leg squared plus leg squared equals hypotenuse squared. And remember, the hypotenuse is always the side opposite the 90, so that's the 16. So we fill our numbers in. I'm going to use x for a, so x squared plus my other leg, which is 14 squared, equals the hypotenuse, 16 squared. There's our equation. All right, 14 times 14 is 196. 16 times 16 is 256. Get x alone, so subtract 196 from both sides. You get x squared equals 60. Then we need to take a square root of both sides. 2 x's, 1 comes out. And this is where you're going to want to use a calculator. And I'm going to make squiggly equals because we're going to round this. When you run this through a calculator, square root of 60 is 7.745. Then it keeps going. So x is 7.745. From this crossbar down is 10. So if I add 10, what I end up with, not x, sorry, is 17.745 feet. So what's important is that the bridge has a clearance of only 17 feet, and the height of the house unit is 17.7. It's already almost a foot too tall, and that doesn't even include the height of the trailer it's sitting on. So your answer would be the house is 17 point, and I'm going to round this, 17.75 feet tall. It will not fit under the 17-foot bridge. And then answer the question. The trucker should reroute. And when you whenever it says explain, you've got math here that you have to show as part of your explanation, but you also have to reach your conclusions in writing. So you state that how tall the house is, you say it will not fit under the bridge, and then answer the question, should the trucker plan a different route? The trucker should reroute. Always answer the question asked. Okay, that's it for today. Nice short section of notes. Have a good afternoon.